Now we move on chapter 5, probability distributions. We have already finished the first 3 chapters, chapter 2, chapter 3, and chapter 4. I know all of the topics in these three chapters are not new topics. Some students will be very familiar with these topics, but from this chapter, probability distributions, maybe this one is totally new to you. So make sure you can read your PowerPoint very carefully and make sure you do the homework practice. Okay? So first section, we will learn some general information about probability distribution. And the second section, we will learn a very special distribution, which is called the binomial distribution. Let's check. We will talk about the definition of random variable, and we also learn the concept of probability distribution. And we will use the histogram to represent the probability distribution. And we can find the important parameters: mean, standard deviation, variance. We should learn the important measures, important parameters from a probability distribution. And most importantly, we should use the probability to determine a value is significant or not. So first, let's check the concept of random variable. So random variable is a variable. It's not a number. It's not a fixed number, right? It's a variable. So we will use the letter to represent the random variable. Typically, we will pick X, Y, something like that, which means the single value determined by chance. So that's called random. Single value determined by chance. So it's called a random variable. And what is probability distribution? So it's just give the probability for each value of a random variable. We will go back to check random variable again. So each value determined by chance. So each value should have a corresponding probability, right? Because it's determined by chance. So each value would have a corresponding probability. And we list the value and the probability. This kind of thing, we call it probability distribution. And we can use a table, a formula, or a graph to represent the distribution. Again, what is probability distribution? First, we list the possible values. Every possible outcomes, every possible values for a variable. Then list the corresponding probability for each value. We can call this kind of thing is a probability distribution. We have 2 kinds of different random variable. The first one, we call it discrete random variable. Discrete random variable. So it is like countable. The values countable. So something like the number of girls, the number of boys, they are all countable number, right? And the number of the heads, if we just toss the coin, How many heads do we have? How many tails do we have? So this kind of variable, we call it discrete variable. The values are countable. Of course, we have another one called continuous random variable. Is not countable. The values not countable. So it can be the body temperatures, the weight, the height, something like that. Let's check the requirements of probability distribution. We have 3 requirements. First, it's a numerical random variable S. Numerical random variable S. And each value are associated corresponding probability. So first, it should be a numerical value. Second, each value has its corresponding probability. So that's called the first requirement. The second one, the sum of all the corresponding probability is equal to 1. The sum of all the probabilities is equal to 1, or very close to 1. Very close to 1, because the rounding error may cause the probability is not exactly 1, but that's still very close to 1. Okay? The last requirement is each probability should be a value between 0 and 1. Of course, this is true for all the probability, right? If it's a probability, it cannot be any number smaller than 0 or any number greater than 1. So this is true for all the probability. Of course, it's true in probability distribution. So if we want to determine one table or one formula is a probability distribution or not, we need to use these 3 requirements to test if all of them are satisfied or not. If each of these 3 requirements is satisfied, then we conclude that one is a probability distribution. Random variable. Number of heads. We call it x. The meaning is the number of heads. So first we will say x is the random variable, and each value, for example, if x equal to 0, which means we got 2 tails, right? If it's 0, x is equal to 0, which means no heads. 0 heads, which means 2 tails. We got this value depends on the chance, right? And if we had one head, one tail, it still depends on chance. Of course, we have another possible value is 2. We got 2 heads. Let's get this value depend on chance. So it's random variable. And we already know we only have 3 possible outcomes, 3 possible values, 0, 1, 2. These all we have 0 heads, 1 head, 2 heads, because we only toss 2 coins, right? Then we list all the possible values in one column, x, called x value, random variable x. we list all of the possible values, 0, 1, 2. And another column, we should list the corresponding probabilities. So for the first one, 0 heads. So how can we get this probability? So we know for the first coin, what's the probability to get a tail? So it's 1/2, right? Times, because it's a sequence of events. The second event, we still get a tail. So what's the probability of getting a tail? It's still 1/2. Here we use multiplication rule, right? So it's 1/2 times 1/2. We got 1/4 for this one. Similarly, for the second one, how can we get the probability of second one? First, we can have this tail, head, or head tail, right? So for one tail or one head event, it's not a simple event, it's a compound event. It can be separated to two different situations. The first one we say is the first one got a tail and the second one is a head. Or the first one is head, the second one is tail. So these tail, head, or head, tail are simple events. Then we try to get the probability for this one. Tail, head. So it's the probability first one to get a tail times the second one to get a head. We got 1/4, right? And for head tail is the same. The first one to get a head, so the probability is 1/2. And the second one to get a tail is 1/2. So another 1/4. So put them together, 1/4 plus 1/4, we got 1/2. That's how we get. And similarly, we will get 1/4 for after we list all of the probabilities, then we have two columns. One column different values, another column probabilities. Now we test if this table satisfies all of the three requirements. So first, we check if this x is a numerical random variable. Then we go back to check. So we have 0, 1, 2. So they are numerical, right? They are numbers. The second way, we check, of course, and each value has the corresponding probabilities. So that's the first requirement. The second requirement, we need to check the sum, so the sigma px. So we get it's equal to 1. That's good. The second requirement is also satisfied. Then we check the last one. So each probability should be a number between 0 and 1. And that's true, right? So all of three requirements are satisfied. So this one is a probability distribution. So satisfy the requirement. And we know it's three possible values. Countable number. So it's discrete random variable. The values are countable. We can also use a histogram. So here the probability histogram is just similar to the relative frequency. But this time this vertical scale, we call it probability, but it's very similar to the relative frequency. So you check the horizontal line, we have different probability for each value. For example, if we check the first value, 0. So we first check the horizontal line to find the 0, right? It's 0 here. So we check the height of this bar, we will get it's 0.25. So we can also check the corresponding probability for each value in this histogram. So this probability histogram is also a probability distribution. So probability distribution can be a table, also can be a histogram. Of course, we can also use a formula. To find the probability for each value. So for example, if we want to know the probability for 0 heads, which means 2 tails, we can just use 0 to replace x. Then we will get 1/4, right? If we want to know 1 head, 1 tail, then we use 1 to replace x. Plug it into this formula, we will get corresponding formula, will be 1/2, and so on. So probability distribution can also be a formula. Okay? Let's check this example. So first, we have this table, right? But we do not know this table is a distribution or not. So we need to check the table. Then we use 3 requirements to test if this is this probability distribution. So remember, what is the first requirement? It's about numerical values for x, right? So here we have random variable x, but this random variable do not have numerical values. If we check here, it's not number. It's not number, right? So first one is already not satisfied, which means this one cannot be a probability distribution. But we can, because this is the example, we can check the other 2 requirements. The second requirement is that the sum of the probability is equal to 1 or should be very close to 1. But we check this one. The sum here is 1.57, so it's not even close to 1. The second rule is not satisfied. For the last one, each probability should be a value between 0 and 1. This is true for all of the probabilities. So the last one is satisfied, but it doesn't matter, right? The first 1 and 2 are not satisfied. So we already can conclude this table is definitely not a probability distribution. So we can check. We get to the conclusion does not describe the probability distribution.